In this video, we're covering section 5.5 trigonometric equations. Let's start by defining a trigonometric equation. It is an equation that contains or with a trigonometric expression with a variable, usually x. So for example, sine squared of x plus cosine squared of x equals 1. That is, so that identity that we've talked about, the Pythagorean identity, is a trig equation. Another one that we'll look at in just a second is sine of x equals 1/2. Now, I'd like to write here also my definition for solution. It is the value or values for a variable or variables that make an equation true. So whatever value we can put in for x that makes the equation true is a solution. So let's look at sine of x equals 1/2 for just a second. We have this graph here. This graph is the sine of x. This is a normal sine function, no transformations occurred. And then we also have this graph of y equals 1/2. Wherever these two graphs intersect is the solution of the equation sine of x equals 1/2. Okay, so we have pi 6 is a solution, 5 pi 6 is a solution, 13 pi 6, 17 pi 6, negative 7 pi 6, and we will have more solutions as the graph continues. We would be able to find these solutions on the unit circle as well. We would look for every place that has 1/2 in the y coordinate for the points. That occurs at pi 6. That occurs at 5 pi 6. So these are all the solutions. So trigonometric equations are different than regular solutions because you can have often an infinite number of solutions. You can also have 3 or 4 solutions that you have to identify and locate. So equations involving a single trigonometric function. We will have multiple trig functions later on. Right now, a single trig function. Isolate the function on one side of the equation and then solve for the variable. Okay, and I will show you, we will take a look at that in example 1. So solve the equation. 3 times the sine of x minus 2 equals 5 sine of x minus 1. When I first start this, what I do is I treat this whole sine of x as my variable. So I'm going to keep this sine of x here together, but I'm going to treat it kind of like I would any other variable. So I'm going to subtract 3 sine of x from both sides. I'm also going to add 1 to both sides. So negative 1 equals, let me actually write, a negative 1 equals 2 sine of x. Now I don't have it isolated yet, so I'm going to divide by 2. So negative 1/2 equals sine of x. All right, so now what I'm going to do is I'm going to look at the unit circle. Okay, so I'm going to find everywhere that the sine, or the y coordinate, is negative 1/2 in the unit circle, and that occurs at 7 pi 6. Okay, so again, the question here is the sine of what angle equals negative 1/2? So that occurs at 7 pi 6 and 11 pi 6. So these are my two answers on the unit circle. Okay, however, they're not the only two answers. Okay, what we have to do is we have to, let's see, let me just draw this out. So here's 7 pi 6, here's 11 pi 6. This is 7 pi 6, but we have to account for going around the circle once. We have to account for going around the circle twice, 3 times, and so on. So here is what we do. The answer is 7 pi 6 plus 2n pi, where n is any integer we choose. So if I choose 7 as an integer and I calculate this value, it will be a solution to this original equation we found it directly from our solved equation. Okay, so 11 pi 6 plus 2n pi. We have two solutions here, and that's how we write them. Now, an important thing to note is these are all of the solutions. They're infinite solutions. Sometimes you will be told, find all the solutions between 0 and 2 pi. Then, if that's the case, you do not have to add the 2n pi part. You just have to find the ones in the unit circle. All right, now let's look at equations involving multiple angles. Okay, so this is tangent of 3x, so it's the angle is a multiple of 3, and this angle is a multiple of 1/2. So if inside the trig function you have just x, you do what we did on the previous problem, and everything works out. If you have something multiplying x inside the trig function, it adds a few steps, and it adds some complexity in how we solve this. So solving an equation with a multiple angle. Example 2, solve the equation tangent of 3x equals 1. Notice this says between 0 and 2 pi. Now I'll make this comment here. Normally you'll see one of these with a or equal to and one not, because 0 is 2 pi. It's the same, it'll have the same value, thinking about the unit circle. So let's start with tangent of 3x plus 1. So when does tangent equal 1? We're going to look at our unit circle. Tangent equals 1 when sine and cosine equal each other. That happens at pi fourths and 5 pi fourths. Now, if you think back to the way we did the tangent graphs look like this. They have a period of pi. And so we only need to look at the values that are solutions from 0 to pi. So 5 pi fourths works, but what I'm going to do is I'm going to go pi fourths plus pi will give me 5 pi fourths. So this 5 pi fourths will be taken into account when I do my plus n pi type of thing here. Okay, so tangent of 3x equals 1 when 3x equals pi fourths. Okay, so it's almost as if we used a different variable and said, okay, tangent of what angle u equals 1? Well, that happens when u is pi fourths, but u is 3x. Okay, so we have 3x equals pi fourths, but I need to add the n pi here. Now, I'm not going to go clear to infinity or back to infinity, but I need to make sure I account for every value in between 0 and 2 pi. Okay, so I'm going to divide by 3, and I have to divide that whole side by 3. So now x equals pi twelfths plus n pi thirds. So again, let's recap. What happened here is we found the tangent of what angle equaled 1. We put what was inside of the tangent equal to the pi fourths plus n pi, n because tangent has a period of pi. If it was sine or cosine, we'd have 2n pi, but we also would have included the second angle. Then we divided by 3, so x equals pi twelfths plus n pi thirds, and I need to find all of these values that are between 0 and 2 pi. Okay, so what I'm going to do now is I'm going to create a chart. I'm going to create n and x. N could be 0. If n is 0, then I would have pi twelfths, because pi twelfths plus 0 pi thirds is pi twelfths. N could also be 1. That would be, write this in a different color, pi twelfths plus pi thirds. If we add these fractions, that would be 4 pi twelfths, so this would be 5 pi twelfths. Now we'll plug in 2 So that's pi twelfths plus 2 pi thirds. Now I already know each pi thirds is 4 pi twelfths, so this is 8 pi twelfths plus pi twelfths gives me 9 pi twelfths. Now, as I do these, I need to ask, have I reached 2 pi yet? Is 9 pi twelfths greater than 2 pi? No, it's not. I'm looking for 24 pi twelfths. Once I pass 24 pi twelfths, then I don't need to keep going. So I'm going to have a 3, a 4, maybe a 5. So we do this again. Pi twelfths plus 3 pi thirds. Well, that's going to be 13 pi twelfths. And then I'm going to go pi twelfths plus 4 pi thirds. Now let me make a comment here about a pattern that we are seeing. Every time we go up, I'm adding pi thirds, correct? And pi thirds is 4 pi twelfths. So I can know this is going to be 17 pi twelfths. This is going to be 21 pi twelfths. And the next one, 6, would be 25 pi twelfths because I'm adding the same each time. Now, we see that 25 pi twelfths is above our 24 pi twelfths, or 2 pi. So here are all the values or solutions to this equation between 0 and 2 pi. So x equals pi twelfths, 5 pi twelfths, 9 pi twelfths, 13 pi twelfths, 17 pi twelfths, and 21 pi twelfths. So we've only done 2 examples so far in this section, and they were solved drastically different. So the key is, if you have merely an x in the trig function, it's fairly straightforward. Figure out the answers from the unit circle and add 2 pi n unless it 2n pi unless it restricts you between 0 and 2 pi. If you have something inside, then you have to do this extra process where I use the plus 2n pi, or plus n pi if it's tangent, and then find all the values that lie between 0 and 2 pi. And we will see that we'll see each of those in additional examples. All right, example 3, solving an equation with a multiple angle. So I've got sine of x over 2 equals square root of 3 over 2. What we're going to do is we're first going to find on our unit circle where sine equals square root of 3 over 2. That means, so the angle we're taking the sine of has to equal pi thirds, or the angle we're taking the sine of has to equal 2 pi thirds. Those are the only 2 places in the unit circle that the sine of an angle equals square root of 3 over 2. Now, we also need to add our 2n pi, because we have a multiple angle. So now, how do I get rid of a divide by 2? I'm going to times by 2. So x equals 2 pi thirds plus 4n pi. Do the same thing to the other equation. X equals 4 pi thirds plus 4n pi. Okay, now we would normally go through the chart again like we did on the previous problem. So n equals 0 will give me 2 pi thirds on this first equation. If I put 1 here though, and I'm going to add 4 pi, would that be above my 2 pi requirement? Yes. So I do not need to really go through the table, but that would be the process if there were more values. And so my other one, from my other equation, when n is 0, is 4 pi thirds. If I put in 1 again, that will be over the 2 pi. So my two solutions are 2 pi thirds and 4 pi thirds. So trigonometric equations, quadratic in form. So now that we've solved a couple 3 trig equations, now we're going to throw in a quadratic trigonometric equation. So let's take a look at these. Here we have 2 cosine squared of x plus cosine of x minus 1 equals 0. This is a form of the quadratic. If you'll see the u substitution here below it, it says 2u squared plus u minus 1, where u equals cosine of x. Okay? And then we have a similar thing over here with 2 sine squared of x minus 3 sine of x plus 1, where u equals sine of x. So these are each in quadratic form. We can solve these by factoring or by the quadratic formula. I think most of our examples will deal with factoring. Example 4, solving a trigonometric equation quadratic in form. Okay, now please note there is only a single x, so I'm not going to have to do the table portion when I get to the end of this equation. So one of the things that is helpful here is if we write it as 2u squared plus u minus 1. For many students, this is easier to grasp and just say, all right, I need to factor this. We can use the area model diamond problem. So I've got 2u squared minus 1. So what multiplies to be negative 2u squared and adds to be u? That's 2u and negative 1u. Finish off this process. So in factored form, it's 2u minus 1, u plus 1, and that equals 0. Okay, you don't have to use the u substitution, but if you do, now at this point, I'm going to put back in cosine of x. Now I'm going to set each of these factors equal to 0. So I've got 2 cosine of x minus 1 equals 0. And cosine of x plus 1 equals 0. And we solve each of these individually. So on this side I have cosine of x equals 1/2, and on this I have cosine of x equals negative 1. Now we are going to look at the unit circle and see where will cosine of x equal 1/2, and that happens at pi thirds and 5 pi thirds. Now, when does cosine of x equal negative 1? Cosine of x equals negative 1 only when x equals pi. So, because there was not a number multiplying the x in the trig function, we don't have to do the plus 2n pi and do the table. And because we are limited here, x between 0 and 2 pi, our answers are only pi thirds, pi, and 5 pi thirds. Example 5, solving a trigonometric equation in quadratic form, or quadratic in form. So this is kind of like the last one, but we don't actually have to factor this one. So I've got 4 sine squared of x equals 1. So we'll divide by 4, so we get sine squared of x equals 1/4. Now we'll square root both sides. So sine of x equals plus or minus 1/2. So we want to know when sine of x equals positive 1/2 and when sine of x equals negative 1/2. Okay, so x equals, we'll look at our unit circle to figure this out. So x equals pi 6 or 5 pi 6. And also, when it's negative, will be negative 1/2 will be 7 pi 6 and 11 pi 6. Now, those are all the answers between 0 and 2, and because there was not any number multiplying by x, we have finished, and those are our 4 solutions. Now, we might also be able to use factoring to separate two different trig functions as an equation. So if we take a look at this, we might be able to move all terms to one side and obtain a 0 on the other side. So we still want to get a 0. But what I can do is I can go tangent of x, sine squared of x minus 3 tangent of x equals 0. Because if I factor out the tangent of x, I'll be left with sine squared of x minus 3, and I get these two to equal 0, then I know I can use the zero product property, and tangent of x has to equal 0, or sine squared of x minus 3 has to equal 0. Now tangent of x will equal 0 when x is 0 or pi. Okay. Now sine squared of x would equal 3, so sine of x has to equal plus or minus the square root of 3. Now the problem here is there is no angle that gives a value when we take the sine of above or below -1. So the square root of 3 is greater than 1. But sine will only go from 1 to -1, so there are no solutions for this equation here. So our only solutions are 0 and pi. Example 7, using an identity to solve a trigonometric equation. This is where we'll use the identities that we've used in the previous sections. And what I notice is I have a cosine squared and a sine squared. I can't factor it out. I can't use a quadratic form. And so what I'm going to do is I'm going to change cosine squared to 1 minus sine squared of x plus 3 sine of x. And that gives me 2 minus 2 sine squared of x plus 3 sine of x, and that equals 0. Okay, so I'm going to rewrite this so it looks more like quadratic form. I'm not going to use the u substitution on this one. And this will factor to become 2 sine of x plus 1. Oh, one step before that. It is often easier to have this first term positive. And so one thing that I can do is multiply both sides by -1. And that'll give me a positive 2 sine squared of x minus 3 sine of x minus 2. And that equals 0. You don't have to do it that way, but sometimes it'll make the factoring easier. Either way you do it, it will still work. When I factor it, I get 2 sine of x plus 1 and sine of x minus 2 equal to 0. So I want to know when 2 sine of x plus 1 equals 0, and I want to know when sine of x minus 2 equals 0. So we'll solve each of these equations. I'm going to start with the one on the right first, because I noticed something. When is sine of x equal to 2? The answer is never. We'll never have sine of x be equal to anything bigger than 1 or less than 1. So there's no solution for that part of the equation. That means if this equation has a solution, it has to come from this side. So I'm going to subtract 1, then divide by 2. So sine of x equals -1/2. We've done that before. I know that that does have a solution. So it looks like from our unit circle, x will equal 7 pi 6 and 11 pi 6. Now I just checked. We do have our qualification here, so I'm not going to add plus 2n pi. And there is no multiple angle inside. There wasn't a number multiplying inside of that x. So those are my only two solutions. Example 8, we're going to use another identity. Okay, so this time we have a cosine of 2x and a sine of x. So cosine of 2x, remember there are 3 different options for cosine of 2x. I'm going to use the one that has sine squared of x because then I will have another quadratic. Again, I see my limitation here. So I'm going to go negative 2 sine squared of x plus 3 sine of x minus 1. I'm going to change all the signs like you did on the previous problem. And then we'll factor. So when I factor, I get 2 sine of x minus 1 and sine of x minus 1. So here, I'm going to be solving 2 sine of x minus 1 equals 0. So that's sine of x equals 1/2. And over here, sine of x equals 1. So when does sine of x equal 1/2? That's when x is pi 6 and 5 pi 6. And here, x is, not 5 pi 6. Sine of x equals 1 when it equals pi halves. So these are my 3 solutions. Okay, example 9, we're going to use another identity to solve a trigonometric equation. Here I see sine of x, and what I'm going to do first is I'm going to multiply both sides by 2. So 2 sine of x cosine of x equals 1. Now 2 sine of x cosine of x, I know that that is a double angle formula for sine of 2x. Okay, so now I do have something in here besides just an x, so I'll have to be careful and use those extra steps required. Sine of x equals 1 at pi halves. That's the only time. So I know 2x has to equal pi halves plus 2n pi. Now I divide everything by 2, and I get x equals pi fourths plus n pi. And now we'll do the table. So nx, so when I put 0 in, I get pi fourths. When I put 1 in, I get 5 pi fourths. Now I'm adding a full pi, and so if I put 2 in, I'm going to be over 2 pi, so we don't need to do that. And it looks like my only solutions are pi fourths and 5 pi fourths. All right, example 10, we'll solve this equation again using an identity. I'm going to square both sides. So that's going to give me sine squared of x minus 2 sine of x cosine of x, because I'm foiling that left side, plus cosine squared of x equals 1. Now, I know that sine squared of x plus cosine of x equals 1, so I have 1 minus 2 sine of x cosine of x equal to 1. If I subtract 1 from both sides, I'll get a negative 2 sine of x cosine of x equals 0. I can get rid of that negative and divide by 2. So I can divide both sides by 2. So this is being multiplied. So I want to know when sine of x equals 0 or cosine of x equals 0. Sine of x equals 0 when x equals 0 or pi, because remember it's the y value, and cosine of x equals 0 at pi halves and 3 pi halves. Now we need to check these solutions to make sure that they all work. Okay, so we're going to check 0 first. And the reason we do this, when we square both sides, it's possible to introduce extraneous solutions. Okay, so is sine of 0 minus cosine of 0 equal to 1? Well, sine of 0 is 0 and cosine of 0 is 1. So does this equal 1? No. So 0 is not a solution. Okay, we'll check the next one. Sine of pi minus cosine of pi, see if that equals 1. Well, sine of pi is 0, And cosine of pi is -1, so this is true. Pi works. Now let's do sine of pi halves minus cosine of pi halves. And this is easy enough. We should just look at the coordinate at pi halves, and we see that the y-coordinate is 1, the x-coordinate is 0, so this does check out, the pi halves. And the 3 pi halves, the coordinates there are -1 and 0, and that doesn't work. And so our only solutions here are pi halves and pi. Okay, example 11. We need to talk about these types of problems using the calculator. What we're going to do is we're going to find the inverse tangent. So x equals the inverse tangent of 12.8044, and that equals 1.4929. Okay. However, we're looking for all the solutions between 0 and 2 pi. This is one of them. Is there another? 1.4929 is in the first quadrant because it's less than pi halves. Pi is a little over 3, so this pi halves would be a little over 1.5. That means there's something in the third quadrant. So if this was, so there's the first quadrant, something in the third quadrant. And so we have 1.4929 and 1.4929 plus pi, and that would be 4.6345. So these are my two solutions for part A. We'll do a similar thing for part B, and we'll do the inverse cosine of -0.4317, and that gives me 1.1244. Now we would think initially, oh, this is in the first quadrant, but remember our cosine was negative and sine is negative in the first quadrant, so this is actually the angle above and below this pi, this part of the x-axis. Okay, because cosine is negative, we know that it has to be in the second and third quadrants. Because tangent was positive over here, I knew that was the first and the third quadrant. So I have pi minus 1.1244 and pi plus 1.244. And that will give us approximately 2.0172 and approximately 4.2660. So now let's use a calculator to do this. What we're going to do is we're actually going to use the quadratic formula. Okay, so sine of x is going to equal, because this is our x value, this is our what we're squaring. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that means sine of x equals 1 plus or minus the square root of 5 over 2. And this is approximately 1.6180. Okay, or negative 0.6180. Now, sine of x equals 1.6180 has no solution, so we're going to ignore that equation. That's not going to be part of it, part of us finding the solution, so we're going to focus on this one. And what we're going to do is we're going to take the inverse sine of the negative 0.6180. Now, I know that the sine is negative in the third and fourth quadrant because the sine is the y-coordinate, so it's below the x-axis. So when I do this, when I take the inverse of that, I get 0.6662. So I'm going to do pi plus 0.6662, and 2 pi minus 0.6662 to figure out my answers. So pi plus 0.6662 equals 3.8078, and 2 pi minus 0.6662 equals 5.6170. And those are my two solutions. If this one had also been able to have solutions, we would have 4 solutions here. And that is the video for section 5.5. Thank you for watching.